Okay, so today we are going to talk about the problem that is the in the college entry examination in China happened in just 2021. So I will talk about two selected problem. The first is the problem is with the triangle ABC. So we have a triangle ABC, A, B, C. So the three sides are the little a, little b, and the little c. And we have the b square equals AC, and the point D is on the AC. Point D is on the AC such that BD times the sine of the ABC is sine B is equal to A times the sine C. Okay, so this is the condition is no. The first is we want to prove BD equals B. So from this one, we know BD equals A times the sine C over sine B, right? And we also need to this one, which one can connect the angle and the side together. That's either the law of sine and law of cosine, right? So here let's try to use the law of sine. The law of sine tells me the side over its sine of this angle equal to b over sine b equals c over sine c is equal to 2r, where r is the radius of the circumcircle Okay. So now if we apply this one back to here, so we have the 4r squared of the sine square b is equal to 4r squared of the sine a times sine c. So we have the sine b squared is equal to sine a times sine c, right? Okay, now let's see this. So we can further change this one also to parameterize as r and its angle, right? It's sine a times sine c over the sine b is equal to this one. You can apply to here. Then it's 2r times the sine b. It's b. That's why the BD is b, right? Okay, so the second, we want to see if AD equals 2DB, DC, right? So we know this is the B over 3. This is the 2B over 3, right? So AD is 2DC. We want to ask you what is the cosine B, right? So it talks about the cosine B, and seems that we can see we can try to parameterize this triangle, right, using the side of the B. Okay, so let's see. I mean, the triangle, the ABC, the area is half of the A times C times the sine B, right? Is also equals to half of the B times HB, right? So we know this is the B square, right? So now we can have the HB is equal to B times sine B, right? Since BD is B, right? So this is the HB, right? So B sine B is equal to HB means this angle is B. This angle is 180 minus B, right? So now let's apply the law of cosine on the triangle ABD, right? So we can know the C square is equal to the B square plus the 2 square of the B square, right? Minus the 2 times the B times the 2 over 3 of the B, then cosine B, right? We can also know that a squared is equal to b squared plus 1 over 3 of the square of the b squared minus 2b 1 over 3 of the b. Then cosine 180 minus b is plus sine b, cosine b, right? Plus cosine b. Now, if we have I call this one 1, this one 2, right, and we know the cosine b is also equal to a squared plus c squared minus b squared minus 2ac. Here we can see the 2ac is 2b squared, right? So it's a squared plus c squared minus b squared. So you can see the a squared and the c squared can be parameterized at b squared with the angle of cosine b, right? So we kind of can construct it equation of the cosine b, right? So the 1 plus 2, so the 1 plus 2 can give us is a squared plus c squared, right? Equals the 2b squared plus the 5 over 9 of the b squared, then minus the 3 2b squared of cosine b, right? So now we can try to take out this one, right? Take b squared is a b squared plus 5 over 9 of the b squared minus 2 over 3 of the cosine b of the b squared, right? Divided by the 2b squared. So this is set aside. We want to apply here. Then this one equals, take out the b squared, is 2 is 1 plus 5 over 9 minus 2 to the 3 of the cosine b. Then this one equals the 9 over 14, right? Is 9 over 14 minus the 9 over 6 cosine b divided by 2. Okay, so now we have the 18 cosine b equal to 14 minus 6 times cosine b. Then we have the 24 of the cosine b is equal to 14. So cosine b is equal to the 7 over 12. Right? Okay, so next question. So we are given a function of the fx of indicated this. We want to see what is the monotonicity of the fx, right? For the monotonicity, we better use the derivative of the fx, right? So for first question, it's very straightforward. If we do the derivative of the fx is the 1 minus log x, right, plus the x, the negative 1 over x, then this is the negative of the log x. Okay, and for the domain, right, in order to make this one make sense, we must have x greater than 0, right? So now let's draw a picture of the f prime derivative of the fx. Okay, so this one is 1 of the 0, then it's like this. Okay, then let's do the second derivative. So we know the curvature, right, is equal to the negative 1 over x. This one is less than 0. So less than 0 means curvature like this, right? Greater than 0, curvature like this. Okay, so now let's see. I mean, we know here this one is fx increase, right? Because it's greater than 0. And in this segment, right, is fx is decreasing, right? Okay, now let's draw the fx. Okay. So we don't have anything at 0, right? But in order to what the approaching of the 0, right? And you can do the fx. If approaching to 0, this is 0 over infinity, right? So that means we can using the equals 1 minus log x of the limit x approaching to 0 over 1 over x is approaching to limit x approaching to 0, right? And we can do the derivative of the numerator is negative 1 over x. Derivative of the denominator is this. So it's limit x to the 0 is x. So it's approaching to 0, okay? Then we have the 1 and the 1, right? So let's see. If x equals 1, we have it at 1. Why we take the 1, 1? Because here is 1, 0, right? We know at 1, 0 it's increasing, right? Because the derivative is greater than 0, and also it's curvature like this, so it will the first segment like this, right? And the second segment, if x equals e, it is 0, right? E and 0, so it will be like this, right? Okay, so now we finished the first part, right? And for the second part, okay, second part is a little harder, okay? So we know if you can see in this one, right? I mean, if you can see fx equals x, let me write it down, log x, okay? So fa is equal to a 1 minus log a, right? So, but you can see here is the b log a log b. Okay, if you're sensitive with this one, we can how to get the a log a, right? Remember, and a log a and 1 over a log a, there is no much difference, because the log a, negative log a is log 1, negative log a is log 1 over a, understand? So that's why the 1 over a log a, there's no much difference. There is you only need to introduce the sign just to flip it, okay? But we need to get rid of the b. So how to get rid of the b? A common way we are using is to divide, okay? Okay, because both a and b cannot be 0, right? The 0 already excluded in our definition. Okay, now if you have this, you can see it's 1 over log a, right? Then it's log a, right? Let's take out negative sign. Okay, this is 1 over log b, right? Let's keep the positive sign. Equal 1 over b minus 1 over a. Okay, now let's move this one to this side, move this one to this side. Now we can have what we have is the 1 over a, 1 minus log 1 over a is equal to 1 over b, 1 minus log 1 over b. See? Now we see, I mean, this one is from algebraic manipulation, right? Then the problem just do all the process reverse to give us that condition. Okay, it let us not to observe it. So now we can see p equals 1 over a, right? And the q equals 1 over b, right? And you know the fp equals to the fq, right? So the goal of the 1 over a plus 1 over b greater than 2 and less than e is equivalently with the p plus q is greater than 2 and less than e, right? Okay, and I also need this picture again. I need to also work on this picture. Okay, let me draw it here. Okay, so here is the picture. Here is the fx, right? It's the 0 0, it's the 1 1, and it's the e0. So its curvature will be negative. Okay, so you can see once we want to pick a p, right? The 1 1 is the biggest number, right? Here is the increasing in this range will be decreasing to range. So you know the f1 is the maximum value, right? So in order to have the pq is have two, p is here, two, q is here, we must have this, right? So now let's see if this is the p, right? And this is the q, right? So if p plus q greater than 2, right? So if this is the delta, then this is the delta, right? So you can see if p is 1 minus delta and the other is 1 plus delta, then this is 2, right? So that means q should be greater than the 2 minus p. This is the 2 minus p, right? So q should be greater than 2 minus p means f2 minus p and fp minus f2 minus p should be less than 0. Right? So we tried, if we can prove this, if we can prove this, okay, it is equivalently okay, but let's prove this, okay? So the g of the derivative of the p is to the f derivative of the p minus the f derivative of 2 minus p, then 2 minus p, there is negative 1 here, right? So this is negative of the, it's this negative of the log p minus the, plus the log of the plus negative of the 2 minus 2 minus p, right, is equal to log of the 1 over p plus log of the 2 minus p is equal to the p times the 2 minus p over 1, right? 1 over this. So you can see, because the for p must be without loss of generality, we can see the p is less or equal than 1 greater than 0, right? So p is less than 1, so that means p is less than 1, right? Greater than 0, okay? So for this one, the p times the 2 minus p, right, is the p is 0 and p is 2, the 2 0 point, okay? It will be like this, right? So this is the 1. So you can see the maximum of the denominator is the smallest number, right? And the minimum of the denominator can be make it larger, right? So you can see within the p in this range, right, the maximum is 1, right? So this number should be greater than the log of the 1 over 1 should be greater than 0, right? So that means the g derivative of the gp, right, the gp should be greater than 1 over p is greater than 0 and less than 1, means the g of the p is increasing when p belong to the 0 and 1. If p is increasing, right, means the gp should be less than g1 is equal to f1 minus f of the 2 minus 1 is 0. Okay, the gp is less than 0, right? Does that mean is it exactly what we want to prove? Gp equal to fp minus f2 minus p less than 0 is we need to do the similar way. We want to prove that p plus q is less than the e, which means the q should be less than the e minus p, right? So in this case, it means, let me duplicate that picture here. So we have x, it's 1, 1, and e0, so it's like this. Okay, so it means the 1, 1 is the largest one. So if that means if this is the p, right? So this is the q. So the q is less than e minus p. So this point is the e minus p. So what we want to prove is we want to prove the fp is always greater than the fe minus p, right? We want to prove the g of p equals to the fp minus the fe minus p is always greater than 0, right? Means its minimum value is greater than 0, okay? So the same thing, we want to see the monotonicity of the GP is the G derivative P is equals the same thing, right? It's the F derivative P plus the F derivative of E minus P. Then it will be equal to the negative log P minus the log of the E minus P. So we can see this one is equal to the log of the 1 over p and the e minus p. Okay, so we are thinking, so this one of the p and the e minus p, because 0 is the else, and this is the 2e, right? So it's centered at the, I mean, this is e is centered at the e over 2 is somewhere is 1.35. Then here is this, right? Because p is less than 1, right? So here is a 1. This one is 1. This one is the e minus 1. This one is somewhere 1.7. And here is the 1 because we take the log. So 1 is an important point. So now we can see over this part, right? So this part is the p of the e minus p, right? So the log of this one should from positive infinity, right? And to this part, so to a certain part of this root is 0, then to here to the 1, right? This is the p equals 1. So this is the g of the derivative of the p. Then this is the 1, so it's negative. So we can see this one is the g of p is increasing. This one is the g of p is decreasing, right? So the smallest value of the g of p is either here, mean value is either here, or mean value is here, right? So in this case, we can see if the minimum of the p is equals to 1, right? So g of p much greater than this is equal to the f of 1 minus f of the e minus 1, right? Okay, so f of 1, what is the f of 1? F of 1 is where the largest value is, right? So of course it is greater than 0, right? Okay, now the other one is g of p greater than limit, because p cannot p can only approach into 0, right? So that means in this case, right, I mean, when p is approaching to 0, now we have the x, right, and the 1 minus the log x, then it's the minus the, this is the p, right? Okay, then the E minus P approaching to E, right? So this one approaching to E. So this part is 0, right? And now is this part, right? Because this part has the infinity, so we have to using the equal to the limit of the P approaching to 0. Then this one is the 1 minus log P over 1 over P is equal to limit P approaching to 0. We take the derivative of the first one is this, take the derivative of the second one is P squared, so it is P approaching to 0 and P, right? So you can see P is greater than 0, right? So that's why the G of the P also greater than the G mean at 0, and it's also greater than 0, right? So in this case, you can see we prove that G of the P is always greater than 0. That means the f of the P minus the f of the E minus P is always greater than 0. So this is exactly what we explained here, right? As long as we can prove this, we can prove the P plus Q is less than E. Okay, so that's about of this problem. Thank you. Bye-bye.